Hi, so now we're going to look at how to visualize networks using NetworkX, which is one of the approaches you can use in Python. It's one of the easier ones to install and use, and it comes as standard within Anaconda if you've downloaded the full Anaconda installation. First thing to think about is how we're going to represent and compute with networks. NetworkX stores things internally within Python. It will hold a single graph for as long as Python is running, or as many graphs as you create, but each individual graph will only stay in memory until Python stops. So it's not a persistent database like Neo4j. It's not really a graph visualization package like CytoViz or GraphViz, which are standalone apps. And it's not really as deeply object-oriented as tools like Mathematica, which can link properties right down into the lowest level objects. Here's our table of nodes. You'll see we've got a node index added this time as well, but that's just a useful thing to have rather than essential. And our nodes are going to be labeled A, B, C, and D again. Each has a location and an arbitrary mean value for some data to put on there. So now I will switch to Jupyter, and the first thing we're going to do is import pandas and load some data. So we'll load in the nodes, and that comes from the node1 CSV file. Once you have the nodes in place, then we're going to have to create an empty graph. So the empty graph is a data structure which will hold a graph, which we will need to build. So we take the node data structure and we add the nodes in one by one to the graph. Alongside the node label, which comes from the node column, we'll also put in the X and Y positions, which we have in the file for each node. So now we have enough to draw the nodes at least, and you can see here what we're doing. We'll take, first of all, from the graph we just created, the positions back into a list of position pairs, and we'll pass those into the draw nodes call from NetworkX. We'll also make the node size a bit bigger and color it pink, get an alpha of 1. And underneath that there's a call to draw the labels, and that will just take the same positions and draw the network labels, so the node labels we added in on top of them, A, B, C, and D, as you see below. So next I've added in some code here to draw the edges. You'll see here we're going to read in the edges from the edge1 file. We're going to create a dictionary to hold the edge labels. So unlike the nodes, we want to create the edge labels from the node labels. So as we add source and target nodes into the graph, we're going to add source and target pairs into a dictionary, and we're going to add to that a string made up of the letter from the source and the letter from the target. So an edge going from A to B will have a label on it, AB. So now we just need to add on the code to the node drawing code that draws the edges. So the first part of this draws edges that are in the graph already, using the same positions as we had before, and we're going to draw the edge labels at the same positions with all edges. Okay, so if we now run this code to draw edges and nodes, we'll find that we get a nicely labeled graph. Each of the edges is labeled from where it's starting from to where it's going to. So BA is there, AD is there, CD is here, BC is here, and AC is here. One small change we can make here is to tell NetworkX to draw directed edges. So directed edges will give us an arrow in the direction of the edge, and you'll see how this works now. So here you'll see each of the edges has an arrow. Unfortunately, edge BA is in error. So BA should be going from B to A, so the arrow should be at the other end. And I've investigated this, I can't find a reason for this, and I think this is an actual error inside NetworkX's drawing tool. So watch out. If you're drawing directed edges, you might be better off using the labels than using the arrows. Now we're going to look at drawing a slightly more complex network. This is the tube network of the central line, so that's normally a circle shape on most maps of the tube, well, a squared off circle shape. Going to import pandas, matplotlib, NetworkX, and we're going to use a library called Pill, which is from Pillow, and the image color is going to allow us to set image colors in a slightly more web-friendly way. I'm also going to use the figure environment to set up an image size that allows us to see the network, otherwise we start to get a bit crowded in certain areas. What we need to do here is create an empty graph and read in the tube network nodes. We're going to do this thing again where we set the index to be an integer. In addition to that, I'm going to add the nodes to the graph. So it runs in the nodes, it changes the index type, and it adds them to the graph. And it keeps here a dictionary of the link between the node index number and the node name, because the node name now is a station name on the London Underground network, but the nodes are actually going to be labelled by an index number. So we do need that dictionary this time. Next, I'm going to add in loading in the edges. So the edges in the tube network, which this is, are the lines between stations. And I'm going to set up a naming scheme whereby I label the lines based on the name of the line. In this case, it's a circle line. So for every edge, whichever direction it is, whatever name it has, whatever edge pair it links between, it'll be called the circle line. So first off here, let's draw the nodes. We've done that. Drawing them white, and this is roughly the right shape and place. One of the problems of running this in Jupyter Notebook is it doesn't draw the shape of the area for the plot large enough. Now we're adding the labels for the stations. You can see here all the stations. They're rather crushed up again here inside the plot that Jupyter creates. One of the things I've done here is shifted the label position compared to the station node position slightly. This code here adjusts the height of the station to be just above where this code here adjusts the height of the station label to be just above the node, slightly up and to the right. Even so, that doesn't solve the problem perfectly, as we'll see a bit later. Okay, so the nodes and the edges are ready and added to the graph already, so I just need to draw the edges between the stations now. So after I've drawn the network labels, I'm going to get a color FFD300, which is a standard color from TfL, Transport for London, for the central line. I'm going to convert that into an RGB tuple. So what this is doing is taking the hexadecimal number, converting it to integer from 0 to 255, then dividing that out so it becomes a floating point number from 0 to 1 in each of the three color channels. And that gives us a color value that we can apply within Python and within Matplotlib. So first off, we draw the edges at the positions that we've got from above, and we draw the network labels, edge labels, which, if you remember, were all the same. I set them all to be the central line for each edge. Because you can't really see the network drawing in Jupyter, I've pulled out the save file that I have from Visual Studio Code. You can save this out from Jupyter 2, I think, and it will be the correct shape and size. So this is the plot it draws. It draws the station name and the station node and the central line, which you will see just about maybe here. On each edge it says central line. So there's some problems here still, that the labels here are very overlapping and it's not very clear which belongs to which. So it's actually Manor here, Cannon Street here, and Monument here, but it might look like Cannon Street's closest to this station. So labeling of networks is really quite a tricky skill. Often you have to intervene manually to get it perfectly right. Most of these work, but not all of them. Okay, so one last thing. I'm not going to go through the code here, but you've got that in the code that you can download with the lecture. I've also added in the Piccadilly line. So I've filtered the data so that within fare zone 1, you have, in this example, the central line around the outside in yellow and the Piccadilly line in a purpley blue colour. You'll notice one thing about it, that in the shared line between Gloucester Road and South Kensington, the Piccadilly line has overdrawn the underlying central line. In Network X, by default, in the standard package, there's not an easy way to get around this. There are some other graph drawing packages where we will draw the arcs, if you remember, like Mathematica did. So you could see both lines at once, but here you just have to choose which one, by choosing the drawing order, which one is on top. And you can see that works reasonably well, although because it's more vertical and horizontal, quite a lot of the station names go through the line. So whereas around here we have a horizontal line and a horizontal label layout problem, here we have a vertical, almost vertical layout problem. You might want the labels just to be to the side of that Piccadilly line rather than in fact on top of it. Okay, so that's the end for this quick introduction of Network X and how to draw things using it. In the next section, we'll look at layout and how to lay out graphs where there's no physical structure that you can lay out for the nodes for, but where you need to use a tool to help you lay out the graph in some way so you can see the nodes and edges. Okay, thank you, That's the end of this section for now.